Good morning, everyone. In our first class in the chapter polynomials, we have discussed four basic points, that was meaning of polynomial, types of polynomials, values of a polynomial at different points, and zeros of a polynomial. Now today we will continue this topic with relation between the zeros and the coefficients of a quadratic polynomial. Now in this topic, what we need to do, let us first take a quadratic polynomial, that is px equal ax square plus bx plus c, where a not equals 0. Why a not equals 0? Because for the existence of quadratic, this x square term must be there, and for that a will never be 0. Since it's a quadratic polynomial, and as we have discussed earlier, it will have two zeros. So let those two zeros be alpha and beta. Now since alpha and beta are the two zeros of ax square plus bx plus c, means x minus alpha and x minus beta will be the factors of this polynomial. So if we multiply these two factors and taking a constant k, we can make it equal to the same polynomial ax square plus bx plus c. So now on solving this equation, that is ax square plus bx plus c, and multiplying the RHS side, we can get kx square minus k into alpha plus beta into x plus k alpha beta. After this, let us compare coefficients of like powers of x on both sides. What is the meaning of this? X square term will be equals to x square term, x consisting term will be equals to x consisting term, and constant term will be equals to constant term. So here you can see the coefficient of x square is a, and here the coefficient of x square is k. So we can write k equals a. Similarly, coefficient of x is b, and here the coefficient of x is minus k into alpha plus beta. So we can write minus k into alpha plus beta equals p. Similarly, here constant term is c, and here constant term is k alpha beta, which means k alpha beta equals c. Now, using this k equals a in equation 2 and equation 3, suppose we are using it first in equation 2, putting this a in place of here k, we can get minus a into alpha plus beta equals b, that is alpha plus beta will be minus b by a. If we use this k equals a in the third equation, so we will get a alpha beta equals c, that is alpha beta equals c by a, which is also called sum of the zeros equals minus b by a, and product of the zeros equals c by a. So this is the basic relation between the zeros and the coefficients of a quadratic polynomial. Again I am repeating, sum of zeros is minus b by a, and product of zeros equals c by a. We can check it, we can verify it with the examples. Let us suppose we have a polynomial 2x square plus 3x minus 9. So first of all, let us find the zeros of this polynomial. How we will find the zeros? Make it equal to 0. By splitting the middle term, we can solve it. We will get the resultant x equals minus 3 and 3 by 2. So these are the two zeros of the polynomial 2x square plus 3x minus 9. Let those two zeros, one is alpha, that is minus 3, and one is beta, 3 by 2. Now in this polynomial, if I discuss about what are the coefficients, so coefficient of x square is a, so we can write a equals 2. Coefficient of x is 3, so we can write b equals 3, and constant term is minus 9, so we can write c equals minus 9. As we have discussed just now, that sum of zeros is minus b by a and product of zeros is c by a. So let us use it here. If we will add these two zeros minus 3 and 3 by 2, that is alpha plus beta, we get the resultant minus 3 by 2. If we multiply this alpha minus 3 and beta 3 by 2 will get the product of zeros, minus 3 into 3 by 2, that is minus 9 by 2. Now let us cross verify the sum and product using the coefficient part, that is minus b by a. So minus b was 3 and a was 2. So this is minus 3 by 2. So you can see sum of zeros minus 3 by 2, minus b by a, minus 3 by 2, both are same. In the same way, we can write product of zeros c by a, that is minus 9 by 2. From here we can get minus 9 by 2. So here we verified that sum of zeros is minus b by a and product of zeros is c by a. Now moving ahead with the same rule as we have discussed, if you go for a cubic polynomial, that is ax cube plus bx square plus cx plus d. Since it's a cubic polynomial, let the three zeros be alpha, beta and gamma. Now, as I have discussed, whatever process for the quadratic polynomial for reaching sum of zeros and product of zeros, the same rule if you will use for that cubic polynomial. So lastly you will reach the place, that is alpha plus beta plus gamma, that is sum of zeros will be minus b by a, alpha beta plus beta gamma plus gamma alpha equals c by a, alpha beta gamma equals minus d by a. So this was your today's topic. Revise it once, twice, thrice until you are not very much confident with this explanation. For this, I will attach a short notes and some related questions with that. Revise it, do the questions. If possible, get some more questions from your books, from internet, from anywhere. Till then, be safe. We'll meet in the next video. Thank you.